Welcome back, dosto. In the previous section, we studied various forms of equation of straight line. Like first form which we studied is slope point form, which is slope m is equal to y minus y1 upon x minus x1. Here m is the slope of the given line and x1 y1 is the fixed point on the given line. Then we studied our next form of equation of straight line, which is 2-point form. In 2-point form, we have two fixed points. One is x1 y1 and another is x2 y2. So the equation was y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So this is the equation of line in 2-point form. Then we studied our next form, which is 2-intercept form, in which we had two intercepts. One is x-intercept, which is A, and y-intercept, which is B. What is x-intercept? X-intercept refers to the point at which the line cuts the x-axis. Similarly, B, y-intercept, refers to the point at which the line cuts the y-axis. So the double intercept or 2-intercept form was x by A plus y by B is 1. Finally, we had another equation which is slope intercept form, which is y is mx plus c. Here m is the slope of the line and c refers to the y-intercept. That means the point where the line cuts the y-axis at 0, c. So y is mx plus c. This is the equation of straight line in slope point form. Then we have the general equation of line, which is ax plus by plus c is equal to 0. We have the slope of this general equation of line as minus a by b. So these are various equations of straight line. 1, 2, 3, 4 and 5. Let us now see sixth form. So next form of equation of straight line is normal form. Normal form, which is also known as perpendicular form. So normal form or perpendicular form. This is the next equation of straight line. So let us study our next equation. So suppose we have x-axis and y-axis as shown, and we have a straight line, which is, let us say like this. This is our straight line. This line is at a distance p from the origin. So this is the distance of the straight line from the origin. P, small p, refers to the perpendicular distance of this line from origin. Let us say this angle here between the perpendicular and the x-axis is alpha. So in that case, the equation of this straight line will become x cos alpha plus y sin alpha, that equals p. Here alpha is the angle between the perpendicular from the origin to the line and the x-axis. So p here refers to the distance of the line from the origin. So let us derive this equation. First of all, the slope of the perpendicular. If I write the slope of this perpendicular line, it is nothing but tan alpha. Why? Because slope is given by the formula tan alpha. This perpendicular makes angle alpha with the x-axis. So slope of this perpendicular, let us say something like OD, slope of OD. This is tan alpha, because OD makes an angle alpha with the x-axis. So slope of this perpendicular, slope of OD is tan alpha. So slope of perpendicular is coming out to be tan alpha by definition of slope. Now after this, if I want the equation of this line, so I will use the formula m1 m2 is minus 1. If two lines are perpendicular to each other, then the product of their slopes is equal to minus 1. We will prove this result in our next section, but for now remember whenever we have two perpendicular lines, in that case the product of slope is -1. So we can say slope of perpendicular into slope of line, this equals -1. So from this I can get slope of perpendicular into slope of line is -1, which gives me slope of line is equal to -1 upon slope of perpendicular. Now slope of perpendicular, we already found it is tan alpha. So let me substitute the value. Slope of perpendicular I will substitute as tan alpha. So from this slope of line is -1 upon tan alpha. But 1 upon tan alpha is cot alpha. So I can say slope of this line whose equation I want to get is -1 upon tan alpha, which is minus cot alpha. So this is the slope which we have found. The slope of the line is minus cot alpha. I want to find the equation of line which is having a slope minus cot alpha. So now let us find the equation of this straight line. So how will we find the equation of straight line? So for that we have to use one of the forms which we discussed. Either we will use slope point form or 2-point form or double intercept form or slope intercept form or general equation. So one of the equations we will use. So which one? Let us decide. So let us now find first of all the coordinates of this point. So foot of the perpendicular. This is the foot of the perpendicular. Has what coordinates? So let me draw the diagram. So this is our straight line whose equation I want to find, and this line is at a distance P from the origin. So this is the perpendicular distance P, and this is the angle alpha here. This angle is alpha. So accordingly this angle is 90 degree because this is the foot of the perpendicular. Now this point here, foot of the perpendicular, will have coordinates P cos alpha, comma P sin alpha. Why? Because in this triangle, let us draw this triangle here. So this is our triangle like this. One is dotted side. Then we have perpendicular, and this is our P distance. And this angle here is alpha, and this is 90 degree. Now, if I want to find this side, this point will have coordinates which are P cos alpha, comma P sin alpha. Why? So for that let us take cos alpha in this triangle. Cos alpha, if I drop one more line from here, so this is our construction and this is our triangle. So in this triangle, if I take this side as x and this side as y, then in that case I can say cos alpha is adjacent upon hypotenuse, which is x upon p. So from this I will get x is p cos alpha. This is our first equation. Then in this triangle, in this small triangle here, this triangle, if I take sin alpha in this triangle is opposite, which is y upon hypotenuse, which is p. So y comes out to be p sin alpha. So y is p sin alpha. So x I have proved it is p cos alpha. Y I have proved it is p sin alpha. Now we have the point on the line which is, let us say, point D, p cos alpha, p sin alpha. These are the coordinates of the point D and the slope of the line which is minus cot alpha. So we have slope of line which is m subscript line which is minus cot alpha, and we have the fixed point on the line. The point on the line is nothing but point D, which is p cos alpha, comma p sin alpha. So let us use slope point form. So what is slope point form? Slope point form we have already studied. It is m is equal to y minus y1 upon x minus x1. So here slope of the line is minus cot alpha. This equals y minus y1, which is p sine alpha, upon x minus x1, which is p cos alpha. So let us now cross multiply. First of all, let me write this minus cot alpha as minus cos of alpha upon sine of alpha. So after cross multiplying, what will we get? Y minus p sine alpha. So sine alpha will multiply with this. So sine alpha into y minus p sine alpha. This equals minus cos alpha into x minus p cos alpha. So let us multiply y sine alpha minus p sine square alpha. This equals minus x cos alpha plus p cos square alpha. Now, taking this minus p sine square alpha on the right hand side and minus x cos alpha on the left hand side, we will get x cos alpha plus y sine alpha. This equals p into bracket cos square alpha plus sine square alpha. But what is cos square alpha plus sine square alpha? It is 1. By trigonometry, we have cos square theta plus sine square theta as 1. So let us remove this because it is 1 itself. So our equation of normal form will come out to be x cos alpha plus y sine alpha is equal to p. So this is the equation of straight line. This straight line, which is at a distance p from the origin, and this perpendicular OD, it makes an angle alpha with the x-axis. Then in that case, we have the equation of this straight line as x cos alpha plus y sine alpha is equal to p, which I have written here. So this is how we derive the equation of straight line in normal form.